Welcome to the Applied Fluid Dynamics course. We're going to start block number 3, which is essentially just energy loss due to friction, and this is a very important part of the course. This is the block which will determine how much energy is lost due to the pipes and fittings, valves, etc. I remember you the reference books and textbooks we've been using. We're going to use right now this booklet a lot. And, well, in Applied Fluid Mechanics, Robert L. Mott, 6th edition, we're going to cover Chapter 8, which is essentially Reynolds number, what's laminar flow, turbulent flow, and, more importantly, friction losses. Then we follow with Chapter 9, which is laminar and turbulent flow profiles, just a little bit, velocity and stress. Then we go to Chapter 10, which is minor losses, which is friction loss due to fittings and valves, and many times these minor losses are not that minor. In the book of Unit Operation of Chemical Engineering from McCabe and Company, 7th edition, go to section number 2, and there is fluid mechanics. We're going to study chapter number 5, which is incompressible flow, basic approach to the friction factor and transportation of fluids. This is very important. Pipe fittings and valves. We're going to study friction. And more importantly, we're going to find out many ways or many data on diagrams and tables in this booklet of the Crane Company, flow of fluids through valve, fitting and valves. And well, let's check out the overview and structure. Once again, 3 sections, section 1, 2, and 3. First section is about flow in pipes. A little bit on the Reynolds number, how to determine laminar flow or turbulent flow, and a little bit on pipe roughness. Then we go and check out what's friction loss and how to calculate it on pipe walls. So this is the pipe, here's friction loss here and here. We start analyzing the friction factor, and there are mainly 2 definitions, smoothing and fanning. We study the Moody's diagram, and then we check out many equations, for example, chain equation for friction factor and many other equations. Then we continue with section number 3, which is friction loss due to installation of fittings and valves, which is named as HFS and HFF for wall pipe. We understand the value of K, what does that mean, how to make the equivalence on the length of pipe, and how to calculate the friction loss of each fitting and valve. So, if you've been tracking this course, probably you know that in AFD3 we analyzed this equation, mechanical energy equation. Previously, this value was given as a number. Well, where does this number come from? We're going to see this right now. We are going to find out how to calculate this number. So ignore all other concepts. We are just interested in this value right here. Once again, I need to tell you that this is broken down into 2, wall friction and fittings and valves friction. So, for example, we have pipe friction loss, which is this HF, essentially pipe is energy loss due to friction, and this F right here is for pipe. Now, for fittings and valves, this is essentially just to shape. We have a friction loss, and we use HF to denote friction loss and S to denote due to shape. So of course, if you add the friction loss due to the pipe and the friction loss due to all the fittings and valves installed in that pipe, you will get the total friction loss. So probably you're asking or wondering, how often do you get a fitting or a valve, or how long is the length of a pipe? Well, imagine this problem. You have this main unit, you have 1 valve, you got 1 fitting right here, you got this length of pipe, you got an elbow, you got the ball valve, you got this huge pipeline right here, another fitting, a drain valve, pipe again, and so on, circulator. All these little fittings right here cause friction loss, and every pipe by nature cause a friction. So we're going to see in this section how to calculate friction. And in this block we're going to see essentially how to calculate friction due to wall, which will be a pipe, and due to each fitting and valve installed in the pipe. So probably this is a very common lab set to understand the friction loss. You have like fitting here, fitting here, fitting here, probably different diameters, different materials, valves. I don't know what's this. You have another like this and so on. And yeah, that's the overview. Let's continue with section number 1, which is the theory behind pipe flow and how fluids flow in a pipe. This was a free preview. You want to get full access, go to my Incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, you were analyzing or studying pumps, you have it here, the pump block, then you have the sections. If you were, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. If you were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.